In our very last video, we are going to look at inference with paired data. So students in AP Biology took a pretest and post-test over mitosis. Mitosis is the process of a parent cell dividing into daughter cells. Have a little science with your math. Below are the scores for 8 randomly selected students. Now, this is all well and good, and we already know how to do a test with 2 samples. And obviously here, looking at these values, I'd be dealing with means, correct, rather than a proportion, because these are not percentages. However, these are not independent, because that is Sean's score to begin with and after, and Bill's score before and after. So these are related, because it's the same student taking both tests. So we cannot use our 2-sample t-test that we used in the past because it does not meet the independence condition. Therefore, we still can do a test, but we're just going to do a paired test instead. So the first thing to understand is that if it's from an observational study, we call it a matched pairs test, and if it's from an experiment, meaning some treatment was applied, then it's called a blocked pairs t-test or t-interval. Quite often you will see it be called a mean of differences test. Now, the reason that it is called a mean of differences test is because essentially what's happening is we're finding the differences and then finding the average of those differences, which is of course why it's called a mean of differences test. In stats, we're not that creative. We just call things exactly like they are. So we're caring about the differences and we're finding the mean of those differences. Note the way that we write our hypothesis is different than the way that we did before. I'm not showing the subtraction. I'm saying that the mean of D, which is the mean of differences, is equal to 0, or it's less than, greater than, or not equal to 0. Again, not a bad idea to say that the differences are found by taking the mean of whatever minus the mean of whatever, which we'll look at in our first example. For assumptions and conditions, obviously, we need to assume that these are paired data. They can't be independent data. If they're independent, we go back to our previous test, which was the 2-sample t-test, or the difference of means. Independence assumption, again, the differences must be independent. Randomization condition and nearly normal condition. So we're looking at the AP Biology pre-test, post-test, and we're using an alpha level of 0.025, and we want to create an interval and do a hypothesis test. So we're going to do the test first. Notice here, I have chosen to let my mean of differences equal my post-test minus my pre-test. Now, why did I do that? Well, because I'm an optimist and I'm hoping that the post-test is going to be higher than the pre-test, and I like that number to be obviously positive. That is why I chose to do it that way. If you do it the other way, it's fine. Like I said before, you're just going to end up with, different signs on your values. My null, the mean of differences, is equal to 0, which of course means the average difference in test scores is 0. My alternative hypothesis is right up here. It says determine if students increased mastery after the unit, which means that their post was greater and so therefore greater than 0. So the average difference in test scores is greater than 0. I've checked my conditions here, which I won't spend any time on. Press pause if you want to read through those. Because the conditions are met, we'll use a student's t-model and a blocked pairs t-test. Now, why is it blocked instead of matched? Because there was a treatment. The treatment was that they learned in the unit. So either via a teacher or videos or reading or something, but there was some sort of treatment that was involved between the pre-test and the post-test. Again, we're going to just use StatCrunch for everything. So here's my data already in my spreadsheet, and again I'm going to go to Stat, T-Stats. This time I'm going to go to Paired. And notice they didn't ask me if I had a summary, they just know that I'm going to be using data. I chose post-test minus pre-test. I suggest you do the same. In this case, we're going to do a test first. So I'm going to click Compute. and I just made the mistake I told y'all not to make. Down here, you have to make sure that you change your alternative hypothesis. I'm really glad I did that so I can show you how easy it is to make that mistake. Post-test minus pre-test, hypothesis test equals 0, and then because I'm assuming that the post-test was greater, then my alternative will be greater than 0. So I click compute. Notice they give me my mean, my degrees of freedom, my t-stat, etc., and my p-value of 0.15. So since the p-value of 0.15 is below our alpha level, we reject the null. There's evidence to support that students scored better on the post-test. Thank God. Now to do the interval, again, if I have to do this, say, for an assessment to submit it, I would just do it again. Stat, t-stats, paired, and I would do post, pre, and make sure you're choosing the appropriate level of confidence. Click compute, and notice I have now found my lower limit and upper limit. Again, if this were for an assessment, I would take a screenshot of both of those at the same time, but notice the way that I'm writing my conclusion. Since the p-value of 0.15 is below our alpha of 0.025, we reject the null hypothesis. There's evidence to support that students scored better on the post-test than they did on the pre-test. I'm 95% confident that the students scored an average of 1.947 and between 1.947 and 28.3 points better on their post-test than their pre-test, which is amazing. And again, this supports our conclusion since 0 is not in our interval. And oh my goodness, this is your very last example. Are you so excited? I know that I am. So press pause. Work this one out. Use StatCrunch to be your little helper. Then press play to check your work. Okay, first check the conditions. We check that they're paired, independent. It doesn't say that they're randomly selected, but we'll proceed because it's good practice for us. Nearly normal, you certainly can check that. Again, if you don't remember how to check that condition, remember I'm going to go to Graph and QQ-plot, and then you just choose whichever one you want. And you can actually choose both of them, before and after, and click compute. And notice this looks pretty good. It's all fairly close to that line. Again, this one, not too shabby. I would be a little bit concerned about this one, but again, we'll go with it anyway. Again, I'm doing a blocked pairs test because in this question, they're actually doing an exercise program and then being tested, so that is a treatment. So that is why it is blocked. My hypothesis, notice I'm going to take after minus before. Now again, in this one you could technically do before minus after because I'm going to assume that pulse rates lowered after people worked out. So I did it backwards this time just to be difficult and just to show you what would happen if you ended up with negative values. So here, mean of differences equals 0. There's no difference between pulse rates before and after. And again, mean of differences is less than 0. So because, this is important, because I chose after minus before, my alternative is less than. If you chose before minus after, then you would assume that number is positive and that should be greater than 0. So the resting pulse rate after an exercise routine will be lower than the resting pulse rate before. Doing these two tests, or the test and the interval, again, I'm going to go to Stat, T-stats, paired. I'm going to choose, I chose after and then before. For my interval, I'm doing a 90% interval. And again, notice I'm getting negative values, and that's okay. That just means that that's how much it lowered. It has decreased by that much. Again, if I go to Stat, T-stats, paired, again, I did after minus before. And my hypothesis test here was less than 0. And compute. And notice here, 0 is not in my interval, and this p-value is very low, so I reject. Just to point something out to you, if I would have screwed up and put this the wrong direction, Notice my p-value is huge, and I would certainly fail to reject. And then if I looked back up here and saw that 0 was not in the interval, I should know that I did something wrong in one of the two. So that's when you go back to the question and you check which one you did wrong. So make sure that those agree before you ever submit anything. So I'm going to switch this back so that it's correct. Again, I would take a screenshot of those two, write my conclusion, talking about how they agree with one another, and that is all, my friends. Congratulations.